Hello guys, welcome to another Project Euler problem. This is problem 14, longest Collat sequence. The following sequence is defined for the set of positive integers. N is equal to n divided by 2 when n is even, or n is equal to 3 times n plus 1 when n is odd. Using the rule above and starting with 13, we generate the following sequence. It can be seen that the sequence contains 10 terms. Although it has not been proved yet, it is thought that all starting numbers finish at 1. Hey, there you guys go. You can write a proof. I'd be very impressed. Which starting number under 1 million produces the longest chain? It's important to note that once the chain starts, it is allowed to go above 1 million. So you guys are smart. You probably have already figured out you need a limit of 1 million, and that you're going to need a long since it's going to go above 1 million. I imagine it will be fairly large. So let's get started on this. As I said, we need a limit of 1 million. We'll make it final since it will not change. And then we'll need a variable to hold the sequence length. So I'll call it sequence sequen. I'll have it equal to 0 since we didn't start any sequences yet. So now we need a loop to go from 1 to the limit, and that's going to be our base number. Let's call that n for simplicity. n plus plus. Man, if I can type today, let me tell you. Okay. Now we're going to need a temporary number to hold the value of n. This is what we're going to do all our arithmetic to from our piecewise function. So we'll have it long because if you take a number like 999,999 and multiply it by 3, I imagine that's going to be a large number. So we're just going to store it into a long to make things a lot simpler. We'll just call this num. We'll have it equal to the base number. Then we need another variable to hold the current sequence length. And since we don't have any sequence to speak of, we'll set it at 0. So here's where things get tricky. It is thought that all numbers end in 1. So since we're not trying to prove this wrong, we need to say while num does not equal 1. Because as far as we are aware, all numbers end in 1. So we want to keep going until num ends in 1. So here we can state our piecewise function. If num modulus 2 equals 0, so that is stated right there, the top line. If it's even, num is going to equal num divided by 2. Otherwise, if it's odd, num is going to equal 3 times num, or 3 times n, plus 1. That's all we need for our piecewise function, and that should eventually end up at 1. But we need to count how many times it does this. So down here, we're just going to increment the current sequence. Okay, so now we have the sequence length, and hopefully this ends at 1. So we have a sequence length, let's say it's like 6. We need to compare it to our highest length so far and determine if it's bigger. And to do that, we'll just say sequence length equals, and here's where we compare the two, is greater than sequence length. Is that true? Well, if it is, we'll set it equal to current sequence. Else, we'll just reset it. I might as well enlarge this for you guys since we're done doing that fun stuff. So let's go back over this. This is our limit of 1 billion. Sequence length, this is going to hold our highest length. N is our base number. It will be the start of our chain. Num is a temporary variable to hold the arithmetic from your piecewise functions. The current sequence holds the current chain length. Sorry. We need this to end in 1. We need num to end in 1 since although it's not proven, we're not trying to prove it wrong, so therefore we're going to assume that it ends in 1. I hope I'm making myself clear there. These are just your piecewise functions, incrementing the sequence length after you do one of these two operations. And then we're just going to assign the highest sequence length to your variable. So that is okay. Everything seems to be checking out. We're going to just systemout.printf %, %n. And here we're just going to put the sequence length. So everything should check out. The highest sequence length is 524. That means that this has the highest number of times it had to repeat this loop is 524 times. We'll find out if that's true right now. Okay, yeah, I'm sorry. We're going to need to grab n, so I found the wrong thing for you guys. I am very sorry. Don't yell at me. So we're going to need to change this to if sequence length is less than current sequence. Sequence length equals current sequence. And highest num will equal n. With a number of %d. There we go. And we'll just throw highest num in here. Okay, there, that's the right answer. Sorry about that last bit. I was in the right mind, I just found you guys the wrong answer. But the highest num is the right answer. It was not asking you to find the chain length, it was asking you to find the number with the highest chain length. I am completely sorry. My mistake. My B. If you guys have any questions, feel free to contact me. Stay tuned for your next Project Euler video. And like I said, if you have any questions, just contact me.